Hello everyone, previously we had discussed on the radix sort. That was the last topic on the sorted algorithms, right? So today let's start with this one, binary search, this one, variants, right? So we'll be we'll be discussing some of the algorithms within the some of the searching algorithms basically, right? So this is fine. Let's start with the binary search variants. When I say binary search variants, it includes lower bound and the upper bound. So this one will be very helpful in the CP. Will be mostly using this one for the optimization purpose. Mostly binary search, most of the times will be making use of it for the optimization purpose itself, right? On the indices, maybe some of the times to find this one element, pure binary search. So lower bound and upper bound, mostly it is used for the optimization purpose, right? So CP or the lead code, especially third one or the fourth problem, right? So the lead code harder one mainly, right? So this is fine. Now let's get into the definition part first. So lower bound is nothing but the index of the first element that is greater than or equal to the target. Some target has to be present, so we have to find certain target, right? So the index of the first element that is greater than or equal to the target in the sorted list. So that is nothing but the lower bound. Then what is the upper bound here? The index of the first element that is greater than the target in the sorted list. Simple, right? So this is about the lower and upper bound, right? So let's move on with the explanation part. This one, binary search can be tweaked to find not only whether an element exists, but also to find the position, nothing but the index, right? So where it could be inserted while maintaining the order, right? So this is very important. Upper bound and lower bound, basically it is used to find the position where it could be inserted while maintaining the order itself, right? So mainly indexing. So that's what I said, right? So binary search can be tweaked to find not only whether an element exists, but also to find the position where it could be inserted while maintaining the order. If you have solved certain problems on the binary search, you would be knowing by this time, right? So we should be knowing certain these things, right? So we have solved n number of problems already on the binary search one, right? So we have to be knowing these kind of algorithms. So now let's get into the let's move on with the further things, man. Lower bound, what it does, it helps find the leftmost suitable position. Just remember this one while writing the algo, it will be very helpful, right? So lower bound, what it does, it helps find the leftmost suitable position. Then what does upper bound do? It helps find the this one, rightmost suitable position just after the last occurrence, right? So lower bound, leftmost suitable position, upper bound, rightmost suitable position. We just have to remember this one. Next, this one is let's move on with the further things. Next point is here, this is extremely useful in the problems like, so these are some of the problems, right? Counting the occurrences of an element, right? So how many number of how many times this one element exists, basically the frequency, counting occurrences of an element, finding the insertion points. This one is the second one. The third one is range queries, nothing but count of numbers less than or equal to this one, x greater than or equal to count of numbers, and x this one, what do we call, or greater than or equal to x, right? So this one, count of numbers less than x greater than or equal to count of numbers, or less than or equal to count of numbers. This is fine. So we will write two functions using the binary search logic, right? So let's start writing the first function then. So what we are waiting for, just write the let's start writing the function. First let's go with the lower bound, then let's go with the upper bound, right? So as usual, so I'll just go with def here, lower bound. This is fine. So let me go with two parameters. One is we need the array, and another one we need target. This is fine. So the next one, let's find the first index where array of index is greater than or equal to target. So this one will be low comma high equals 0 comma length of the array. So this is fine, man. So while let's go with the while loop here. While this one low less than high, this is fine. We don't have to go with this one, right? So I forget this is Python many times. While low less than high, so then what we will do, so we have to calculate the mid, pure binary search. So this one will be low plus high, right? Low plus high by 2 to calculate the mid, right? So after calculating the mid, if the mid value is less than target, then we have to discard the left part, this one left part, sorry, nothing but we have to assign the low to mid plus 1, right? So let's write the simple if condition first. So this one, if array of mid is less than target. So then what we need to do here, we have to discard the left part, meaning I'll assign the low to mid plus 1. Simple. Next, else if the mid value is greater than the target, right? So if the mid value is greater than the target, then the possible answer, this one, we have to move left, right? So how can I write that one in the form of code? So let me assign high to mid, right? So this is fine, man. Finally we have to return low, right? So we have to return low. For that, how can I write this one? So let me come here. Yep, I'll just return low. This is fine. Now let's do one thing. Let's go with one more function, def upper bound, right? So I'll just go with upper bound. So this is fine, man. Let's go with array also target. So this is fine. Now let's find the first index where array of index is greater than the target, right? So let's go with this one, low comma high. Let me assign this one to the 0 comma length of array. This is fine. Yep. Let me go with while loop here. While low less than high, then what we'll be doing here, so let's calculate the mid equals low plus high, so this one by 2. Also, if mid value is lesser than or equal to target, then we have to go right. So let's write the simple if condition here for this. So this one will be if array of mid, if less than or equal to target, then what we should do, we have to go right, meaning I'll just assign this one to the low to the mid plus 1, right? So this is simple, man. Else if the mid value is greater than target, then the possible answer, we have to go left, right? So here, how can I write this one in the form of code? Let me assign the high to mid, right? So also finally we need to return, right? So what we need to return? We need to return low, basically. We need to return low. This is fine, man. Now let's go with the this one, example usage, or right, example usage. So let me consider some random array elements. This one will be 1 2 4 4 4 6 7 9. This is fine. 1 2 triple 4, this one 6 7 9. This is fine. Target, let's consider target, let's consider 4, right? So this is fine, man. Now let's go with the print. So this one will be the print. So this one will be array. Initially let's just print the array. So why this is not considering, man? This is not showing here. What happened here? What's wrong? Just give me a second here. Was not closed. Huh? Which one is not closed here? We have closed the array here. 1 2 triple 4 6 7 9 I have considered. Oh, this one I haven't given comma here, man. Bro. Yep. Now this has to work correctly. Right, so I'll go with one more print statement here. So this one will be target. So this is fine. Let me give target here. This is also fine. Now let me go with the lower bound and the upper bound. We have already written two functions, right? I'll just go with LB, nothing but the lower bound. So let me call lower bound here function. Let me pass, what are the parameters we need to pass here? Array and the target. So this is fine. So next let me call the upper bound here. So upper bound, let me go with upper bound. This is fine. Let me go with array and target. So this is fine, man. Now let's go with the two print statements again. So I'll just go with print. So this one lower bound, let me go with index here. This is also fine. Also let me call lower bound. This is fine. And again one more print statement here. So this will be upper bound index. So this is fine. Upper bound, right? So sorry, UV. This is fine. So we are done with this, we are done with the algorithm basically, right? So we are done with the example usage as well. So now if it works properly, so what is the output that we need to get here? So we have considered array 1 2 triple 4 6 7 9. This one I'm speaking of, line number 43, right? 1 2 triple 4 6 7 9, and the target we are considering here is 4, right? So lower bound we have to get this one, first one, lower bound, this one 0 1 2 index 2, right? So lower bound index we are printing here, lower bound index nothing but 2, and the upper bound index we have to get this one 0 1 2 3 4 basically, right? So 4 or 5. So this one upper bound, yeah, so I got confused, sorry. This one upper bound index we have to get this one index 5 basically, right? So we are printing the upper bound index, meaning so the first element whose value is greater than 4, target we have considered 4, upper bound is nothing but the first value or the first element that is greater than 4, the first value that is greater than 4 we are considering. So here in this case it is 6, right? So where is 6 present? The index number basically 0 1 2 3 4 5, right? So at the index 5 6 is present, which is greater than the value 4. We have to print this index, right? 5. So we have to get the first, we are going with the target 4 where it is present at the index 2, that nothing but the lower bound, and second we are going with the index 4 basically, index 5 whose value is greater than 4, the first element whose value is greater than 4 basically, right? So this is 6, 2 and 5 is what we have to get basically, right? So let's check the same. I'll just give here control J. So let me type Python followed by, let me copy this one file name, we paste it over here .py. So array we are going with 1 2 triple 4 6 7 9, target we are going with the 4, lower bound index 2 and the upper bound index 5, which is absolutely correct, man. We are getting the desired output, right? So let me explain whatever we have done. So this one we are just printing the initial array, this one whatever the input that we have considered, right? So this one line number 46 I am speaking of. Line number 47 what it does, so we are considering the target 4, which shows that we are searching for the target 4 basically, right? So this one 47, so target 4, this is fine. Now we are going with a lower bound index 2, this one whatever the output that we got, this means that the first 4 is at the index 2. So this one first 4 we have to print, right? Lower bound in the sense, so the first 4, so how many times 4 is repeated here? We have 4 3 times within the array, right? So the first time that the 4 is present at what index that we are displaying. So here 4 is present at the second index, so that's what we have got here, lower bound index 2, right? So this is fine, right? So that's the first position where array of I is greater than or equivalent to 4. So in this case we have to get 2, we have got the correct output, right? So upper bound index we have got 5, means it means that the first number that is greater than 4, right? First number that is greater than 4, so here we have 4 again in the third index, 4 again in the fourth index as well, we have 6 in the fifth index, we have 6 in the fifth index which is greater than 4. So this is the first index which is which contains the value that is greater than 4. We have to display 5 here in this case, we have to display 5 here in this case, right? So now we have got the lower bound index 2 and we have got the upper bound index 5, right? So this is fine. So which means the first number greater than 4 is at the index 5, which is quite obviously 6, right? So the range of all the 4s is from 2 to index 4, right? So range of 4 is from 2 to 4, right? So and the upper bound minus lower bound will be 3, that shows that there are 3 occurrences of the 4, right? So this is helpful in this way as well, right? So this is it for the binary search variants, mainly lower bound and the upper bound. So this will be very helpful if you are giving CP. We will be making use of this one, upper bound, lower bound, many times, hell number of times. I have used this one n number of times, right? So within the code forces and the code chef basically, I'm not gonna lie, right? So whenever this one extreme optimization is needed, when the constraints are tight, so we'll be going with the binary search variants, mainly this one, lower bound and the upper bound. Basically when we want to go with the logarithmic and this one, right? So time complexity at that point of time we'll be making use of it, right? So you have to know this at any cost. So basically when you are solving problems of when you are solving the problems after C, right? So problem D, problem E, problem F, those kind of problems needs extreme optimization most of the times, right? So at this point of time, these kind of algorithms are very handy. I'm not gonna lie, this will be very handy. You have to know this you have to know this at any cost, right? If you are giving contests or if you are doing CP, right? So this is very important, I'm not gonna lie. So this is fine. Now yeah, we are done with the binary search variants, nothing but lower bound and the upper bound part, right? So let me summarize whatever we have learned so far. So just keep these things in the mind. Let me tell you one thing here. Let's start with this lower bound. Lower bound, what it gives here, it gives the first index where array of I is greater than or equal to target. We know this, just keep this in mind. Upper bound, what it does, upper bound gives the first index where array of I is greater than target. Keep this in mind as well. And both can be implemented using modified binary search. Just keep this in mind as well. So these are useful for counting the occurrences, finding insertion positions, and range based queries, right? So this is important, right? So this is it for the binary search variants, right? So this is one of the important algorithms, right? So this is fine, man. Next, what we will do, next we will be discussing the this one, binary search on the rotated array. That is also one of the this one important algorithms. Today we are done with the binary search variants algorithm, right? So two algorithms, two functions, basically the same algorithm, two functions, upper bound and the lower bound, right? So we are done with this. For now, this is it. Thanks for watching, guys.